Well, howdy there, Internet students. It's Mr. Hermanson again. Today we're going to learn how to take samples to try and guess what a population is. Now, in real life, this is used to figure out populations of people, populations of animals, maybe to figure out who is most likely to win an election, different things like that. We're going to do it with blocks so you can get a feel for it, but so what we're going to do is use a sample and probability to guess how many of something there is. Okay. Now, you can go ahead and read all this to get an idea about what these samples are used for. But I'll get it right into it. Now, if let's say there's 100 blocks in a bag, and in that bag there are 5 black blocks. Well, if you just take samples out of that bag, you should get black blocks in a ratio that's the same as the ratio of the number of black blocks in the bag. So, so about 1 out of every 20 times you draw a block out of if there's 5 out of 100 in there, about 1 out of every 20 times you should get a black block. So if you take samples and you combine those samples, you should get close to the average probability. You don't have to, though. I mean, because anything can happen. You could pick, you could never pick a black box. I mean, it's theoretically possible. But if you did it an infinite number of times, you should get the same number of blocks as out of 100 as there are black blocks in there. So we're going to do where there's 20 blocks in a bag, and we're going to try and guess what color they are, okay, by taking some samples. So, and we thought it would be easier to take bigger samples. That way it wouldn't take quite so long to do this. So on our first sample, we got a yellow, a blue, a red, and 2 greens. On the second sample, we got a green, a yellow, a blue, and a red. And on the third sample, we got a red, a green, a red, a blue, and a yellow. Now, since we have 3 samples, and we always put them back in before we took our next sample, we can combine these samples and just pretend that we took, there's 5 in each, a sample of 15. Okay? And out of those 15, we can figure out how many are each of the colors, yellow, blue, red, and green. And then we have a rough idea of what is actually in the bags for each of those colors without actually having to take them all out. All right, so so let's just total up what we have out of the 15 samples. So we have 1, 2, 3, 4 yellows. We have 1, 2 blues. Doesn't seem like there's too many blues in there, does it? We have 1, 2, 3, 4 reds. I don't know why I used a green pen to do reds. That was kind of silly, wasn't it? Okay, and how many greens do we have? 1, 2, 3, 4 greens. Okay, so in our sample, we have 4 out of 15 that are yellow, 2 out of 15 that are blue, 4 out of 15 that are red, and 4 out of 15 that are, I think I counted one of them wrong, didn't I, you guys? It looks like there's 3. And the reason I figured that out is because I should have had 15 total, and they didn't add up to 15. So you really should make sure that these add up to how many total that you had in your sample. All right, now we're going to use probability. Okay, we're going to say, not probability, we're going to use a proportion. Since 4 out of my 15 were yellow, that should proportion out to some number out of 20. And to figure that out, we're just going to solve this proportion. So 4 times 20 divided by 15 equals about 5. Since you can't have part of a block, we'll just round that to 5. 5 yellow, okay? 3 out of 15 are blue, so I'm going to change this to 3 now and do the blue. So I'm going to do 3 times 20, which is 60, divided by 15 is 4. And then 4 out of 15 is going to be the same as yellow, 5 and 5. Okay? So that's what we predicted, that we would have about 4. Now, since there's 20 blocks, we might change our prediction and just think it's pretty close to even. So maybe there's an even number and all. We don't know for sure. So we're not going to do this actual. We would have had to do that in the classroom. Okay. But, so let's try another one here. Here we took 5 samples. There's 10 colored discs. And we're going to try and figure out how many of each color are in there. So count the yellows, count the blues, count the reds, and count the greens. Once again, make sure your total adds up to how many are in this sample right here. Okay, you should have got that. Now I'll do the yellow, and just to remind you how to do it. So in our sample size there was 20. 2 out of 20 of ours were yellow, and we want to know how many that would be out of 10. So we're going to do this proportion. 2 times 20 divided by 20 is 1. We think there's 1. Okay? You do the rest of them. See if you get them right. Okay. We should be predicting that you are going to usually get red, so most of that group of 10 should be reds. And notice all these kind of add up to 10 total. Okay? Now, if you wanted a more accurate prediction in either of these, just take a bigger sample. Take more samples. The bigger the sample, the closer you're going to get to the theoretical probability. Okay? All right. We're going to do a bigger one now. There's 100 blocks in this bag. We want to know how many of each color there are. Okay? To do that, Callie and Kevin each took a sample. Okay? So we're going to count them. So we're going to count the reds, the greens, the yellows, and the blues. Go ahead and do that. See if we get the same total. Okay. So we got 8 out of 20 red, 6 out of 20 green, 2 out of 20 yellow, and 4 out of 20 blue. Now, another way you could scale this up to 100 and make your prediction is just figure out how many times a group of 20 goes into 100. And that's 5. So multiply each of these by 5 would be another way to do that. So 8 times 5 is 40 red, 6 times 5 is 30 green, 2 times 5 is 10 yellows, and 4 times 5 is 20 blues. All right, well, you can go ahead and try some of those problems. Let me know if you have any questions. And other than that, we'll talk about this next time we meet. Good luck.